Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a quick discussion about the workflow of using AI in software development. It all started from the tweet that I have here from Paige Bailey at the Dynamic Web page. Very nice pun. Our studies reveal that when solving a coding task with Copilot, programmers may spend a large fraction of total session time on just double-checking and editing suggestions and spend more than half of the task time on Copilot-related activities. Together indicated that introducing Copilot into an IDE can significantly change user behaviors. And then there are a bunch of visualizations. This also mentions another tweet that links to the original study. So this brought to my attention this idea of using Copilot or any other AI tool in software development. Now, I haven't actually used Copilot with software development, and one of the reasons is, what I will talk about today, the fact that I think it fundamentally changes the way in which you interact and do software development. And I'm not yet certain that it does that in a good way, that it actually increases productivity or helps and so on. I have been using AI in the meantime on various things. Mostly I've been using the Bing chat because that's the easiest one to use. And I found that for my goals, the Bing chat has been quite at a low level. I mean, I would equate Bing chat with something like junior researcher. It knows how to gather information from the web, put it together, give you links, but then you have to validate. And that's basically what we discussed in one of our previous videos on these topics, that whenever you're using an AI, a large language model, one of the generative AIs, is that the process will be the following: write a prompt, use the prompt to generate something, and then the last step is verify. And if you're doing this on a very limited context, it's likely that you'll be able to verify quickly with a glance and so on. But the question is, if it is on such a small and limited context, wouldn't you actually be able to do it by your own and in a similar time or faster? If you are doing this for a larger context, what you'll get is a bunch of statements that you need to verify in detail because of a few problems. So one problem being that LLMs hallucinate. So they basically invent new things that don't exist. Now, since I haven't used Copilot, I don't know how much it does hallucinate, or if it actually does hallucinate. And we'll talk a bit about this problem at the end of the video. But for now, let's look at this, because this is a very interesting study. So basically what they did is, it's called Reading Between the Lines, Modeling User Behavior and Costs in AI-Assisted Programming. It's done by a few researchers from MIT and Microsoft Research. So one researcher from MIT, 3 from Microsoft Research. And what they are saying is code recommendation systems such as Copilot and Co-Whisper have the potential to improve programmer productivity by suggesting and auto-completing code. However, to fully realize their potential, we must understand how programmers interact with these systems and identify ways to improve that interaction. To make progress, we studied GitHub Copilot, a code recommendation system used by millions of programmers daily. We developed CUPS, which is not the printing system from Unix, but a code recommendation system used by, a taxonomy of common programmer activities when interacting with Copilot. Our study of 21 programmers, so this was run on 21 programmers, completed coding tasks and retrospectively labeled their sessions with CUPS, showed that CUPS can help us understand how programmers interact with code recommendation systems, revealing inefficiencies and time costs. Our insights reveal how programmers interact with Copilot and motivate new interface designs and metrics. All right. So basically what they have is this CodeRec user programming states, short name CUPS, and it's a taxonomy. Or another way of saying this is it defines types of activities that you do when using one of the, in this case, GitHub Copilot. And you see that you have a bunch of things like thinking about new code to write, not thinking, waiting for a suggestion, writing new functionality, editing written code, editing last suggestion, writing documentation, prompt crafting, debugging, testing code, looking up documentation, deferring thought for later, thinking, verifying suggestion. And as you can see, something interesting here, thinking, verifying suggestion ends up being around 22.4% of the time. So let's say it's 20% roughly. This means about 1/5 of the time. So for every 5 minutes, 1 minute you spend verifying that what GitHub Copilot has given you is correct. And this is in line with what I was expecting, because again, this will be, if we want to do prompt-based engineering, fundamentally this will be how it works. We'll take a context, craft a prompt, get an answer, verify the answer. And then based on that, we'll either do some more prompt crafting, maybe regenerate, and so on. Now, if you add to this, so let's say roughly 20% verifying suggestion, roughly 10% of the time prompt crafting, and then you wait for suggestion, about 4%. Let's say this is, we can ignore that. So at least 30% of the time is spent on doing this stuff, and then editing last suggestion, that's another one, 12%. So I'm not sure what this is, we'll take a look, but it's either recrafting the prompt or editing the code that you got. So this shows that, you know, as I was expecting, there's a lot of time spent in these phases, right? And we can go into more details. Honestly, I'm not that good at reading these kinds of papers, although this paper is quite easy to read, but I'm pretty sure I will miss some important things. But you see how they define this taxonomy and how they grouped things, and we can visualize a lot of stuff. So I won't go into more details here. You can find the study by yourself. I'll put it in a link. But I think what's interesting is, so large fraction of total session time, 34.3%, double checking an edited suggestion, more than half of the task time, Copilot related activities, what this shows me is that it's yet unclear whether this helps or not. Because the question is, if you're doing this yourself as a programmer, so would it take you less time than this? On the other hand, I feel that, and I actually created a meme about this, we keep complaining that we have no time to write tests. But test-driven development can serve the same types of goals and maybe even more. Because if you're looking at this, let me go back to the initial times that they showed. Debugging and testing code 11.3%. So question is, if you do this in a test-driven development manner, you could probably reduce debugging and testing, remove prompt crafting, remove verifying suggestion, and you'll end up maybe with some more research to do. So you'll probably add some more time for researching. But my feeling right now is that you'd probably get a better result or even result with using TDD rather than with using Copilot. Now, there's no reason you cannot use both. And actually, I think one of the ways that makes sense in which you could do prompt-based engineering is to combine TDD with prompts. And so let's take as an example, you take a user story and say, okay, write me the list of acceptance criteria for this user story. And this could be one of the AI assistants. The next assistant could be take this user story and this acceptance test, and this acceptance criteria, and write a bunch of tests that cover this acceptance criteria. And then you might also have things like, okay, you write the first test, or write the first test for me, then give me an implementation for it, and then keep going in these cycles, which have the advantage of being with a very small context. So because they are with a very small context, it's less likely for the AI to give you bad results. Okay. So I'm still pondering, and I wanted to show you this, but I don't have any final conclusion right now. It's not like we cannot use or we shouldn't use AI at all for software development. I think we'll end up using AI anyway. But the question is, where is the sweet spot? Where does it make sense to actually use it? And we need to do this kind of experiments, both in this very scientific manner, but also empirically, to figure out kind of how long do we spend on GitHub or on AI-related activities, and how much on problem-solving activities. So yeah, that's an interesting thing. And since I mentioned hallucination, there's a very interesting article on the news stack about how to reduce hallucinations from large language models. The large language models, the term hallucination refers to the tendency of the models to produce text that appears to be correct but is actually false. Here is how to minimize hallucination. Here is how to avoid them in your own prompts. It's even worse than that. There was a case recently in US where two lawyers have used ChatGPT to research and to generate their documentation for a lawsuit. and ChatGPT actually generated case files that didn't exist. And because they didn't verify the case files, they ended up basically being auditioned by the judge, because it's a big breach the in the way a lawyer should act, right? So lawyers are responsible for verifying everything that they sign. They signed without verifying that those cases exist, and then when the judge asked for information about the cases, they asked ChatGPT and it generated the cases, and they posted those without verifying that they actually exist, and so on. So it was a big mess for them. If you want to learn more about this, there's a very fun channel called The Legal Eagle on YouTube, where you can learn more about these topics. So pretty cool. And this is the hallucination problem. So now let's see the techniques to reduce hallucinations. And they come up, first they describe a few prompts that generate hallucinations. Consider feeding the large language model with the following prompt: describe the impact of Hitler's moon landing. And of course, there was no moon landing in Germany in 1930s, but an LLM could generate such a text stating that there actually was a moon landing. So the next question is, why do LLMs hallucinate? They hallucinate due to several reasons. The models are trained on vast and varied data sets which can be incomplete, contradictory, or even contain misinformation, which significantly influences the LLM's response. LLM relies solely on their training data without access to external real-world knowledge. This is less the case for things like Bing Chat, which actually searches the internet, but on the same time, there's no reason for it to find only good information. It could find also bad information. As a result, their output may include irrelevant or unasked details. Furthermore, overfitting, where LLMs are too closely aligned with their training data and struggle to generate original text, which is another important factor related to leading to hallucinations. It's also important to understand that LLMs don't have the ability to perform a fact check. They generate responses based on patterns, not on any moral or factual judgment. So basically what an LLM does is to look at the possible next word or possible next group of words and say, statistically, this is the one that fits best. Right, so it doesn't look at the statement, it doesn't understand it logically, and so on. All right, so then techniques to reduce hallucinations. One-shot prompts. One-shot prompts refer to a way of instructing an LLM where the model is given a single example or instruction and expected to understand what to do based on just that prompt. So suppose we want the model to translate English text into French. One-shot prompt might look like this: translate the following English text to Spanish. Hello, how are you? Okay, so there's a mistake in the article. It's actually translating to Spanish. Okay, so as I said, if the context is small, then it's more likely for the output to be precise and correct. If the context is large, or the more freedom you leave to the AI, the more unlikely it is that you'll get something useful. And then there are a few others, like write a poem about a beautiful sunset, write a short story about a robot who falls in love with a human, and so on. Then the second category is few-shot prompts. Few-shot learning is a way of instructing LLMs where the model is given several examples and expected to understand the task based on those examples. This method is often used to nudge the model into understanding the context and format of what's expected. And they give us an example. When we want the model to continue a number series, a few-shot prompt might look like this. Example 1, input 2, 4, 6, 8, output 10, 12, 14. Example 2, input 5, 10, 15, 20, output 25, 30, 35. And then continue the series 3, 6, 9, 12. We can see that first case multiples of 2, and they continue with multiples of 2. Second example multiples of 5, and they continue with multiples of 5. And third example multiples of 3. And the answer would be, given the pattern in the examples provided, where each sequence increases by a constant value, the series you provided increases by 3 each time. Continuing the series, the next values would be 15, 18, 21. Right, so you could do a lot of things like this where you do basic. So from examples, you expect an extrapolation. And apparently, this reduces the risk of hallucinations. Then the third one is context injection, a technique used to improve the performance of LLMs by providing them with additional information that supplements the prompt. This can be done by providing the LLM with additional text code or other relevant data. Context injection involves embedding additional information into the prompt to provide LLMs with the knowledge they may need to respond appropriately. Lack of context is the key reason why LLMs hallucinate. Exactly what I was talking about. And they give an example when Google's Bard was asked about the champions of the Indian Premier League 2023, responded with the response shown in the below screenshot, which is factually incorrect. Now I know very little about cricket, but basically generated some incorrect paragraphs, like 2, 3, 4, 5 paragraphs. However, after feeding with some context based on this news article, it came back with the correct answer. So once you fed it with the right context, it gave you more correct answers. A nice thing about, once again, about the one that I used, about Bing Chat, is that it uses the currently open web page as context. And this helps you when you are doing research. So you can start things, you can ask what, based on the page that you are into, that you have opened, bunch of information. So it quite works with this kind of context injection, is kind of built in. Now, question is, can we use this in software development? And this is where I think it would be nice to have some way of feeding things like, this is the user story first, these are the acceptance tests, this is kind of documentation related to it. And then based on that, to get a better context for what we are trying to solve. And then, of course, there is another context, which is a much more technical context, like in Java, in Spring, in this controller class, what can I do to solve problem X? This is another place where you could have these assistants help you. But hey, the final question is this easier to do or more productive to do than things like test-driven development? Or are they comparable? Or could we combine them in smarter ways? And as usual, we don't yet know the answers. These are just experimental things. I think that these tools will change, will evolve, and the ecosystem of programmer augmented by AI will keep moving forward in one way or another. And I'm really curious to see where it goes. If you're using such a system, let me know. Let us know in the comments. So is it useful? Does it help you? Do you feel it's slowing you down? Have you measured whether it's actually slowing you down or not? Because you could go into the flow of working with this system and not realizing how much time you're actually spending on the AI stuff instead of on the problem solving stuff. I'm really curious to hear from you, so let us know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart.